Hello, this is Feng Guang. I'm come from. I will introduce Combat CI to you. It's a developer-friendly, open free software test service. Combat CI is developed in the OpenEuler community and is designed for testing the operating system because OpenEuler is a new distribution. So we will run RPM builder to build packages and to also run PKG builder to build tests. And besides OpenEuler, we also support other root FS like Debian, CentOS, Arch Linux, etc. And we realized that it's not enough to test OpenEuler packages because it's often too late when bugs are found there. So we want to test push forward or shift left the testing to the upstream wrappers. As soon as the upstream developers run git push, we want to start the test. Up to now, we have been running over 20,000 upstream wrapper. We will monitor so many wrappers and to build tests for them in the first time. And our test metrics aims for testing a variety of kind of tests like build tests, functional tests, performance tests. And we also would like to test the full open source software stack from kernel to all kinds of middleware and applications. We also support test boxes like Docker, virtual machine, and bare metal hardware. And up to now, 3 architectures are supported, like ARM, x83, and RISC-V. When dealing with metrics, there may be an explosion of components and their parameters. And Combat CI is designed to help developers deal with these larger parameter space. This is a basic form of the job. A job is basically a unit that you can submit to the infrastructure and let it run and get results. In each job, it basically describes what kind of script you want to run and its parameters, and what kind of environment you want to run that script. The environment can include the software, kernel, and hardware test box. We support 3 kind of test boxes here. And when you submit the job, it will a corresponding test box will be allocated and will put the kernel specified here will be loaded, and the rootfs and values will be loaded too. Normally, it's an NFS rootfs, and there will be overlaps on top of it, so that the rootfs can be made read-only, so that different kind of test clients will not interact with each other. And the kernel panic in the client won't panic the integrity of rootfs. And on top of levels, there will be various packages installed. The packages will normally be dependent on the exact workload you want to run. Different workloads will require different packages to be installed. Currently, we support these kind of different metrics. For example, operating system. Mainly, we support OpenEuler, CentOS, Debian, Arch Linux. We currently run 20,000 package build tests. Package build are from Arch Linux. And kernel tests we cover then config builds. For performance benchmarks, we will reuse and extend the LKP tests. This is currently available rootfs that you can set in the job. For test boxes, if it is a bare metal server, it will directly PXE boot, and the PXE boot will HTTP get from the scheduler to get a job, and it will send back a PXE script for it to boot. For others kind of test boxes, you have to write a provider script for it, for each kind. For example, if we want a VM test box, the provider will run exactly the IPXE HTTP request. Then it will pass the content and convert it to a wget command. Then to download the kernel and init.rd, then run it with libvirt or QEMU. For container, the protocol is more simple with JSON HTTP, and commands are similar. Android is possible, but for now we have not implemented it because it's not the priority now. The test box can be described in YAML like this to the provider scripts. Given these parameters, then it can create a QEMU instance correspondingly. And our test infrastructure would like to help developers get the bugs fixed, not only to report bug. Because I myself is a developer, I know I can feel that pain when dealing with the tests. Normally, for example, the bisected is an invaluable tool for avoiding very hard debug process. And we provide a common bisect flow for any project and any LID. LID are automatically catch the code by the framework when the test run. For example, if there is boot fail, there will be such a LID. The key part is the error name. The value is always 1 to indicate whether it show up. For one test case, for example, LTP, there is open test case. The test case can be encoded in the file, or the exact file type can also be encoded. For kernel, the message is automatically caught and converted to LID. So if your test case trigger a kernel panic, this framework can automatically catch it. And then there is SDDERR. If your test script will produce some error message in SDDERR, they will also be converted to error message. So the framework will try to catch all kind of LIDs and make them available for bisect. Besides bisect, there is also a bigger requirement for how to effectively reproducing or debugging a bug. In many test framework like Travis, Travis, if you push code to GitHub, then it will do test for you and report back. That's the typical loop. However, to better help the developers, especially in these two, especially if the test case is too complex to be reproduced in local environment, or if the remote hardware has different architecture than the developer's local environment, then it's normally not possible to reproduce it locally. So we provide another two connection to the test farm. You can when we report errors, we will attach the test job. That job is the YAML file contains all parameters or environment info enough to just rerun the job. So you got the job, you can submit it back to the infrastructure and to reproduce the problem. You can also if that is not enough, you want to just log in. It's also possible to submit a special borrow job. That special borrow job is very simple. It just contains sleep workload in it. So you can because we think reproduce and the environment is so important. We make it very simple to log in. One single command is enough. With this command, you can allocate the test box, deploy OpenEuler on it, then run the borrow sleep. Then you can the SSH is automatically run for you. So one single command, you can log into the environment. And if you borrow it for 1 hour, then that will be available for 1 hour for you. You can play whatever things in it. In order to make that possible, the underneath implementation goes like this. When the user submit a job to the scheduler, he will get a tweet with HTTP post request. Then the job will sit in the queues. When the test box is available, is either when he finished the last job, he will contact the scheduler with a GET request to get the next job to run. Then the scheduler will, based on this YAML format, it will create the IPXE script for the test box to run. And in this IPXE script, it will contain the all values like kernel and job and the basic depends, including the architect of the framework itself to run in the test box. And this kernel parameter is also possible to specify in the test job. These two are auto-appended based on this operating system specification. This means we will need to create a overlay-FS over this NFS root. We currently support these access types for rootfs. The most simple one is indifferent FS. It's just loaded into the memory, then boot is done. When the access type is NFS or CFS, we will first do a dry cut in the RD, and this init will responsible for creating mounting the NFS from the server, then create an overlay path for you. Then everything return the test workload return will be returned to DRAM. The last type is local disk mount. This may be necessary if you are really care that you want to run in some native environment. Like it mimics a local install. It will basically async the root FS from the NFS server to local disk and boot from it. LVM snapshots will be created so that it can be the async can be reused next time. When you got to the job, got a report, and that report normally associated with the job, and you can modify the job in many different ways in order to debug the bug. For example, if you want to try another machine, then you can modify the test box line. If you want to try another root FS, then modify the OS or OS version. Or you want to just modify the test parameter or to try another commit. It's also possible and convenient. Just modify it and submit it. At last, if you want to run the job, then at the same time you would like to start a SSH daemon, it's also possible. Then you can just log in when the test runs. And we would like to create a mutual beneficial test alliance between operating system vendor, hardware vendor, and software projects. Because basically a lot of things can be standardized and shared. Based on the standardization, we can create a common test case pool and the common set of tools. For example, if you want someone add a HTTPD benchmark, then in Combat CI it could be reused by many parts. For example, the web server projects, also the kernel QEMU compiler projects, and also the open system or hardware vendors. Because when this test workload runs, it will reflect many dimensions in the environment, from hardware to kernel to the web server, and all of these can be treated as one dimension to compare, like here. If we want to compare two different operating system version, then it will show you the result. If you want to compare different, like two NGINX version or two QEMU version, that's also possible. If you want to compare two kind of machines, it's also possible. So the data can be used differently by different parts. Also, like the original output, like the IOStat, the framework will convert it to normalize the metrics like key value pairs. The key is a metric name, value is some float number. Then these will be merged into job YAML and then saved to Elasticsearch database. Finally, this Elasticsearch database can be queried by different kind of tools and to do different kind of jobs like bisected, like report, like a compare in different dimensions. Every kind of parameter can be treated as one dimension, and also visualize the data series or do some accounting and analyze. So it's possible that we come together and share and improve the same set of tool chain to make it really powerful for getting the most out of the data. And to make it easy for others, third party to run our framework, we make it very easy to deploy. Basically, it's a set of microservices that run in more than 60 containers. If you run bring up these containers, the server side is basically up. And we also do a small script to deploy it in to do minimal deploy. Yeah, it's possible. You can try it out in one single virtual machine. Every path can be installed there, like the client, the database, various servers, also boxes. Because you typically cannot run another machine in one virtual machine. Canvas CI is open source. You are welcome to try it out and contribute back. Thank you. Any questions?
That was a great session. Thanks, Nguyen. Let's just wait a few minutes in case there are a few questions. We have just 2 or 3 minutes left. I guess it was all perfectly clear. Great explanation. So there were around 40 attendees. So thanks very much, everyone. And we'll see you shortly with the next session.
Okay, thank you. See you.